Settle in close and let your thoughts loosen the way they do just before sleep, because tonight we drift back to a time before rockets belonged to nations or headlines, back to the small rooms where the whole idea began as little more than a private itch to build something that could climb higher than a kite, higher than a roof, higher than anyone's expectations of an ordinary evening. If this quiet workshop hour feels like your kind of place, leave a comment with the tool or smell you'd most want to find on an old workbench, and consider liking or subscribing for more restful history. Picture, if you will, a garage with one bare bulb hanging from a cord, its light pooling over a workbench scarred by years of small projects nobody outside the family ever heard about. There is a smell in that space that never quite leaves, a mixture of machine oil, scorched metal, and the papery dust of old notebooks. And if you breathe it in slowly, you can almost feel the hush of concentration that used to fill such rooms on weekend afternoons. It was here, in this modest hush, that the dream of flight beyond the sky first became something you could hold in your hands, not as a vision from a novel or a Sunday sermon on the future, but as a set of measurements scratched into a margin, a coil of wire wound just so, a jar of chemicals mixed with the kind of care usually reserved for baking bread. The people who gathered in these places were rarely famous, and many of their names have softened at the edges the way names do when they are spoken mostly by family and old friends rather than by history books. They were engineers by instinct rather than by diploma, machinists who had learned their craft from an uncle or a wartime factory floor, and quiet dreamers who read too much and slept too little because their minds kept wandering toward the thin blue edge of the atmosphere. They wrote to one another slowly, by post, trading sketches of nozzle shapes and half-formed theories about how a flame might be persuaded to push rather than simply burn. Some of these letters, so the stories go, crossed oceans, carried in the same unhurried way a recipe might travel from one grandmother to another, refined a little more with each retelling, each correction folded gently into the next. Small clubs began to form here and there, often no larger than a dozen members meeting in someone's basement or the back room of a hardware store after closing. They called themselves societies, with an earnestness that might seem almost touching now, printing simple newsletters on mimeograph machines that left purple smudges on eager fingers. Within those thin, ink-heavy pages were reports of tests that had gone wonderfully wrong, sketches of fins that someone swore would fly straighter than the last attempt, and gentle, ongoing arguments about whether solid or liquid fuel held more promise for the future. Imagine the quiet pride of seeing your own name in print for the first time, listed among contributors to something that already felt larger than any of them, even when the hardware in question was barely the size of a broom handle. The materials they worked with were usually whatever could be found, scavenged, or bartered rather than purchased new, since money for this kind of hobby was almost always in short supply. Surplus parts from wartime stockpiles found their way into these workshops through friends of friends, a valve here, a length of tubing there, each piece turned over in the hand like a puzzle waiting to reveal its purpose. There must have been a particular thrill in discovering that a discarded oxygen tank or an old artillery casing could be reborn into something that might, with luck and patience, leave the ground entirely. The lathes in these garages were often small and slightly worn, inherited from a father's tool shed or bought second-hand at auction, their motors humming with a familiar, comforting unevenness as brass and aluminum were coaxed into shells and couplings under careful, sometimes trembling hands. Filing metal by lamplight was slow, almost meditative work, the kind that leaves your fingers smelling faintly of oil long after you've gone to bed, and it taught these early builders a patience no lecture could have given them. Picture a young man, sleeves rolled to the elbow, drawing a file across a rough edge again and again, checking the shape against a hand-drawn template, adjusting by fractions of an inch until the metal finally matched the vision sketched in his notebook the night before. Winding wire for igniters demanded a similar stillness, coil after coil laid down with the concentration of someone threading a needle in dim light, aware that one loose loop might mean the difference between spark and silence. And then there was the mixing of propellants, handled with a caution bordering on reverence, small batches measured out on kitchen scales borrowed, we might guess, without always asking permission first. Early experimenters combined ordinary substances in extraordinary proportions, guided by half-remembered chemistry lessons and rumors passed along the newsletter grapevine, testing tiny amounts in tin cans behind the shed before ever trusting a mixture to something meant to fly. Weather mattered more than you might expect in these small trials, since a little humidity could turn a promising batch damp and sluggish, and so many surviving notebooks are dotted with weather notes scrawled beside the chemical measurements, a quiet record of clear skies or unexpected drizzle that might explain why one afternoon's fire burned bright and clean, while another merely sputtered and died in the grass. Those notebooks, on the rare occasions they survive at all, read more like diaries of devotion than records of triumph. Page after page holds accounts of small failures described with surprising gentleness, as though the writer had made peace with disappointment long before it ever arrived. A typical entry might describe a launch that rose only a few feet before tumbling sideways into a hedge, followed not by despair but by a careful list of possible causes and a quiet resolve to try again the following Saturday. There is something deeply comforting in reading these old accounts now, in sensing how ordinary the extraordinary once was, how a boy with a homemade rocket and a notebook full of second tries was, in his own small way, rehearsing for a future none of them could quite picture yet. Correspondence between these enthusiasts often carried the warmth of true friendship, even when the writers had never met in person and lived continents apart. A letter from one hobbyist to another might open with news of a recent test, drift into speculation about nozzle geometry, and close with a question about a spouse's health or a request for some rare part that could only be found overseas. These exchanges built, slowly and almost invisibly, a shared body of knowledge that no single workshop could ever have developed alone. Each small discovery passed along like a cutting from a garden, meant to take root somewhere else and grow a little taller than before. Public demonstrations, when they happened, tended to be modest, half-improvised affairs held in an empty field just outside town, watched by a handful of curious neighbors and perhaps a local reporter, hoping for an easy human interest story. There are legends, not always easy to confirm at this distance, of small crowds gathering at dusk to watch some homemade device rise briefly into the sky before losing its nerve and tumbling back to earth, the onlookers clapping anyway, charmed less by success than by the sheer nerve of the attempt. Whether every detail of these old stories is precisely accurate hardly matters now. What lingers is the feeling behind them, the sense that something ordinary was quietly becoming extraordinary, one Saturday afternoon at a time, one small failure closer to something that might actually work. It would be easy, looking back from the vantage point of gleaming launch towers and orbiting stations, to overlook how essential these humble beginnings truly were, and yet every careful notebook, every scavenged valve, every letter exchanged between strangers who shared nothing but a stubborn fascination with the sky, laid down a kind of quiet sediment that later generations would build upon without even realizing it. The engineers who would one day design towering rockets capable of carrying human beings beyond the pull of gravity often traced their earliest spark back to exactly this kind of tinkering, to some half-remembered afternoon spent watching a small device rise and fall in a backyard clearing. Its brief flight burned into memory far longer than its actual altitude ever justified. There is a particular kind of patience required for this sort of work, one that modern life sometimes forgets how to practice. It asks you to accept failure not as an ending but as information, to write down what went wrong with the same steady hand you might use to record what went right, trusting that enough small corrections will eventually add up to something larger than any single attempt could ever be on its own. The tinkerers of these early years seem to understand this instinctively, perhaps because they had little choice, working as they did without institutional support, without guaranteed funding, and often without any real certainty that their hobby would ever amount to more than an unusual way to spend a weekend. And yet, almost imperceptibly, something was shifting beneath all that patient repetition. The scattered clubs and correspondence networks began, without quite intending to, forming the outline of a community with shared standards and slowly growing ambitions. Newsletters that had once reported mainly on backyard mishaps began printing more careful technical drawings, more detailed accounts of successful ignition sequences, more thoughtful debates about safety that hinted at a coming maturity none of them could yet name. The speculation that had once lived mostly in imagination and rough pencil sketches was hardening, bit by bit, into something closer to method, the loose talk of dreamers giving way to the steadier habits of builders who wanted, more than anything, to see their creations fly a little farther, a little straighter, a little more reliably than the last attempt. As you drift off tonight, imagine that quiet garage once more, the bare bulb humming faintly above the bench, the notebook open to a fresh page waiting for tomorrow's weather and tomorrow's small correction. That patient rhythm of failure and adjustment, of letters sent across oceans and lessons shared without fanfare, would soon carry these early dreamers out of their sheds and basements and toward something sturdier and far less forgiving than a backyard clearing, toward the first real test stands where their careful little fires would finally have to prove themselves against gravity in earnest. When their first real test stands soonest gets a meal of, then will we carry this dream. So let the garage light dim now, and let that fresh notebook page settle into shadow, because the story is ready to step outside into open fields and quiet hillsides, into the places where those careful little fires finally had to answer to something larger than a workbench. Picture the test stand rising up out of scrub grass or gravel, a modest wooden or steel frame that looked almost like a scaffold for some unfinished building, and beside it, a huddle of figures in canvas coats, breath visible in the cold morning air, moving with the unhurried care of people who had already learned, more than once, that haste was the surest way to lose an afternoon's work in a hiss of flame or a spray of frozen oxygen. There was no glamour in these early mornings, no fanfare, only the low murmur of voices checking one another's steps, the clink of wrenches against fittings, the soft scrape of boots on frost-hardened earth as someone circled the stand one more time before anyone dared reach for a valve. Quiet ritual, repeated so often that it settled into the bones of everyone who took part. First came the loading of the tanks, a slow and deliberate business because propellants in those days were unpredictable companions, sometimes sluggish, sometimes eager to bite back at the smallest mistake. Someone would kneel by the fill line, watching gauges creep upward with the patience of a person waiting for water to boil, while another stood a few paces off with a checklist scrawled in pencil, reading each step aloud, not because the words were mysterious, but because saying them aloud made it harder to skip one by accident. Valves were checked and checked again, fingers tracing over cold metal to feel for the faintest hiss of a leak. Ears tuned for a whisper of sound that might mean trouble brewing somewhere unseen, and only when every whisper had been chased down and every gauge had settled into its expected place did the little group finally begin to withdraw, walking backward at first, then turning to walk properly, putting distance and a low earthen berm or a stack of sandbags between themselves and the stand, because they had already learned through smoke and scorched wood and a few singed eyebrows that curiosity was a poor substitute for shelter. Then came the waiting, and it is the waiting, more than the fire itself, that seems to have shaped so much of the culture growing up around these early tests. There was a hush that fell over a test site in those final seconds, a stillness thick enough to hear the wind moving through dry grass or a distant dog barking on some neighboring farm, utterly unaware of the small drama unfolding nearby. Someone's hand might hover near a switch or a lanyard, waiting for a nod, waiting for the last voice on the checklist to confirm that all was ready, and in that pause it is easy to imagine the mixture of hope and dread that must have sat quietly in each observer's chest, a private arithmetic of how many hours of work, how many redrawn diagrams, how many small arguments about pressure and flow had led to this one narrow moment. When the igniter finally did its work, the result was rarely the triumphant roar imagined later in films and folklore. More often it was a cough, a stutter, a brief tongue of flame that either caught and steadied into a thin, controlled roar, or died away into a disappointing sputter, sometimes trailing an ugly plume of black smoke that told its own story before anyone said a word. And it was in the after, in the slow walk back toward the stand, once the flame had died and the metal had been given time to cool, that so much of the real work quietly took place. People often think of rocketry's history as a story of dramatic breakthroughs, but it might be truer and kinder to those who actually did the labor to call it a story of careful returns, of engineers and machinists and enthusiastic amateurs walking back towards scorched steel with notebooks in hand, ready to read the wreckage of a test the way a doctor might read an X-ray, searching for the hairline crack, the discolored patch, the telltale streak of soot that would explain why the engine had underperformed or leaked or simply refused to light at all. Someone would run gloved fingers along a nozzle, feeling for warping. Someone else would trace a fuel line back to its source, checking each joint, each fitting, for the faint dampness that might mean a seal had failed somewhere along its length. And almost always, someone was already sketching a small correction on a scrap of paper, a slightly different valve timing, a slightly thicker gasket, a slightly longer wait before ignition, the kind of modest adjustment that rarely made for exciting reading later, but that quietly, patiently moved the whole enterprise forward one small step at a time. It would be pleasant and simpler to say that one lone genius sat at the center of all this early testing, offering brilliant insights while others merely followed instructions, but the truth, as it usually is, seems far more tangled and far more human than that comforting picture allows. Different accounts credit different figures with the earliest careful test stand methods, and it is worth admitting honestly, even now, that historians still argue, gently but persistently, about who first insisted on withdrawing to a safe distance before ignition, who first proposed keeping detailed logs of each attempt, who first suggested rewiring an igniter circuit in a particular way to avoid a stubborn misfire. Letters between early experimenters sometimes claim credit rather generously for their authors, and later biographers, eager to build a tidy narrative out of a messy record, have occasionally smoothed over those competing claims into something far more certain than the original evidence actually supports. What seems safe to say, without overreaching into legend, is that no single mind held all the answers, and that the slow accumulation of caution, of checklists refined after each mishap, of habits passed quietly from one small team to another through shared letters and visiting engineers, mattered every bit as much as any single flash of inspiration ever could. Consider, for a moment, the ordinary people who did this work, because it is easy for names to blur into vague shapes labeled simply pioneers, when in truth they were people with cold hands and tired eyes. People who spent long afternoons rewiring an igniter that had failed for the third time that week, muttering about faulty connections, then trying again with the same patient stubbornness that had carried them through every earlier disappointment without complaint. There were technicians who became remarkably skilled at reading the subtle language of gauges, learning to sense from a needle's slight hesitation that a valve was sticking or a line was partially blocked somewhere out of sight. There were young assistants whose main job, for weeks at a time, seemed to be tightening the same set of bolts over and over, checking torque values with a care that might have seemed excessive to an outsider, until one remembers that a single loose fitting could mean the difference between a clean test and a genuinely dangerous failure. These were not glamorous roles, and most of the people who filled them left behind no memoirs, no famous quotations, only entries in logbooks noting pressures and temperatures and brief, understated remarks like Slight leak at joint 3, corrected, or ignition delayed, cause uncertain, still under review. The failures themselves, when they came, were rarely catastrophic in the way later imaginations might picture, but they were failures all the same, and they left behind smoke and disappointment, and sometimes a faint smell of scorched metal that lingered in the clothes of everyone who had stood nearby for the rest of the day. An engine might light beautifully for a few seconds, only to sputter and die as some internal imbalance starved it of fuel at just the wrong moment. Another might roar to life with more violence than expected, rattling the stand and sending a small shower of sparks into the grass, prompting a calm scramble with water buckets that had wisely been kept close at hand from the very start. There are accounts, some more reliable than others, of engines that cracked their casings under stress, of fittings that blew free under pressure, of small fires quickly and calmly smothered by people who had clearly rehearsed, if only mentally, exactly what they would do in such a moment. And after each of these events, once the smoke had cleared and nerves had settled back into something like steadiness, the same quiet process began again: inspection, discussion, adjustment, and the slow rewriting of procedure that would, bit by bit, make the next attempt just a little safer than the last. It is tempting, lying here in the dark, to imagine this as a swift and thrilling progression, one dramatic test after another, each bringing some obvious leap forward, but the historical rhythm was far gentler and far more repetitive than that romantic picture suggests. Weeks might pass between tests, filled with machining new parts, waiting for replacement fittings to arrive by mail, or simply gathering the courage and the funding to try again after a disheartening result. Small teams often worked in relative isolation, hearing only secondhand through letters or the occasional visiting engineer about the successes and failures of similar efforts elsewhere, so that progress crept forward less like a single unbroken line and more like many small candles being lit separately in the dark, each illuminating its own modest circle without always knowing how close its light stood to another's. And when those circles did overlap, through correspondence or shared publications, ideas passed back and forth with a mixture of generosity and quiet rivalry, each group eager to learn from another's mistakes while still hoping, in some private corner of ambition, to be the one remembered for the next real advance. What emerged from all of this slow labor, more than any single spectacular success, was a culture, a particular way of approaching dangerous and uncertain machinery with patience rather than bravado. The checklists that grew longer after every mishap, the habit of standing well back before ignition, the practice of recording even the smallest anomaly in a logbook, all of these became part of an inherited discipline passed down through the growing community of rocket experimenters, long before any formal organization or agency existed to enforce such caution from above. It was a discipline built not from confident declarations, but from scorched nozzles and disappointing sputters, from long afternoons of rewiring and retightening, from the humbling lesson learned again and again that fire and pressure demanded respect rather than mere enthusiasm, no matter how sincere that enthusiasm happened to be. And it is worth remembering, drifting towards sleep now, that this same careful rhythm of testing and recording and adjusting did not stay confined to the open test stands alone, but soon began flowing back indoors as well, into rooms filled with drafting tables and machine tools, where the lessons written in soot and scrawled in logbooks would slowly be translated into steadier drawings and sturdier parts for whatever quiet test would come next. So let the soot and the scorch marks settle for a moment, and let your thoughts drift indoors, away from the open fields and their trembling test stands, into rooms that smelled less of scorched metal and more of pencil shavings, machine oil, and the faint mineral tang of graphite dust, because before any rocket could rise even a few careful feet into the air, it first had to exist as a drawing, a patient argument made in straight lines, and long before that drawing became a nozzle or a bracket or a pump housing, it had to survive the quiet scrutiny of someone leaning over a drafting table with a T-square in one hand and a soft pencil in the other, checking and checking again whether an idea born of enthusiasm could actually be trusted to hold together under fire and pressure. Picture the drafting room itself, if you can, in that dim and steady light that seems to belong to no particular decade, only to the patient work of thinking made visible. Long tables tilted at a comfortable angle, each one topped with paper stretched taut and pinned at the corners, waiting for lines that would eventually become steel. The T-square slides down in one smooth motion, and a triangle rests against its edge, and somewhere nearby a slide rule waits within easy reach, its beveled edges worn smooth by fingers that have already solved 100 small problems that day, and expect to solve 100 more before the light fails. There is no glow of a screen here, no soft hum of some hidden machine doing the arithmetic invisibly behind the scenes. Every calculation must be walked through by hand, digit by digit, decimal point by decimal point, and rechecked, because an error tucked quietly into a drawing might not announce itself until it appeared, much later, as a crack in a housing or a leak at a fitting, far from the safety of the drafting room and far too late to correct with an eraser. It is worth lingering on the eraser, actually, since so much of this work depended on it. A drawing worth trusting was rarely a drawing produced in one confident pass. It was a drawing revised, softened at its edges by rubber and graphite dust, redrawn slightly to the left or the right as a dimension proved wrong, or as a machinist down the hall sent word that a certain thickness of stock could not be had that month, and that the design would need to bend itself around the shortage rather than the other way around. These conversations rarely happened all at once in a single decisive meeting. More often they crept along through notes passed hand to hand, through a foreman pausing at a drafting table with a puzzled expression, through someone walking the length of a shop floor simply to ask, quietly, whether a given tolerance was truly necessary or whether it had been chosen out of habit rather than need. And more often than seems fitting for such earnest work, the answer that came back was a shrug, an admission that no one quite remembered anymore why a certain dimension had first been chosen that way, only that it had worked before, and so it was kept, out of the same instinct for caution that had already been passed down from the test stands. From the drafting room, the finished lines traveled down the hall or across the yard to the machine shop, and it is here that the abstract began, slowly and without ceremony, to acquire weight. Picture a mill's bed sliding beneath a spinning cutter, throwing off curls of metal and thin, bright ribbons, each pass shaving away just enough material to bring a rough block closer to the shape a drafter had imagined weeks before. Picture a lathe turning a length of steel or brass, the machinist standing close, one hand steady on the cross slide, eyes narrowed not from strain but from the particular concentration of someone listening for the sound a cut should make, because a good machinist learns to hear trouble in a tool before it shows itself in the metal. A high-pitched squeal, a slight chatter in the surface finish, a change in the color of the swarf curling away from the workpiece. Any of these might mean a feed rate needed adjusting, or a cutting edge had gone duller than it appeared, and either way the work would pause, briefly, until the small trouble had been listened to properly. There is a particular kind of pride that belongs to this work, quiet and rarely spoken aloud, the pride of a part that fits the very first time it is offered up to its mate, a threaded fitting that turns smoothly onto its opposite number, without forcing, without the faint grinding hesitation that tells everyone nearby that something was cut a few thousandths off from what it should have been, a bracket that seats flush against its mounting surface without a shim slipped underneath to make up the difference. Machinists did not often celebrate such moments with words. More often there was simply a short nod, a setting aside of the finished piece onto a felt-lined tray, and a returning of attention to whatever came next, because there was always something coming next, and the small satisfaction of one correct part was quickly folded back into the larger, unglamorous rhythm of the shop, a rhythm that asked for steadiness far more than it asked for celebration. That rhythm depended enormously on measurement, on the unglamorous instruments that made precision possible at all, Calipers, snug in their leather cases, carried from bench to bench like small trusted companions. Micrometers, their thimbles turned with 2 fingers and a thumb, checked and rechecked against a shop's dependable standard before anyone trusted a reading enough to act on it. Gauge blocks, kept clean and lightly oiled, stacked in careful combinations to verify a dimension that mattered too much to be left to a single instrument's word alone. None of this was thrilling in the way that a rising plume of flame out on the test stand might be thrilling. It was slower than that, quieter than that, closer to the patient rhythm of someone doing careful arithmetic by lamplight, checking a sum twice, simply because the cost of being wrong seemed to loom so much larger than the small tedium of checking again. And this patience, more than any flash of inspiration, was what allowed the drawings to become something real. And there was filing too, more filing than most people imagine when they picture the making of something as grand-sounding as a rocket. A rough-cut piece, fresh from the mill or the lathe, rarely stepped directly into its intended role. First, it needed to be freed of the small imperfections that clung to any cut surface, the tiny burrs and shavings raised at every edge where metal had been parted from metal. A machinist would draw a fine file along an edge, feeling for roughness the way a hand might feel along a plank of wood for a splinter, smoothing what needed smoothing, easing what needed easing, so that a part meant to move against another part would not gouge or bind or wear unevenly in exactly the place where such wear could least be tolerated. Deburring was not a glamorous word, and it never earned anyone particular recognition, but it was one of those unremarked habits, like double-checking a valve before a test firing, that quietly kept everything else from unraveling later on, sometimes months later, sometimes only once a part was finally under pressure and had no more patience left to give. Between the drafting room and the machine shop stood a whole choreography of handoffs, and these deserve a gentle pause of their own, since so much could go wrong in the space between one department's confidence and another's caution. A drawing might travel from a drafter's table to a shop foreman's desk, annotated in the margins with a question about tolerance, and travel back again with an answer, and then travel forward once more once the answer had been folded into a revised line. A part machined to specification in one shop might need to mate days or weeks later with another part machined in an entirely different shop by someone who had never seen the first piece and would only meet it, so to speak, at final assembly. The drawings were meant to make such meetings unnecessary, meant to let 2 strangers, working from the same careful lines, produce pieces that would slide together as though they had been made side by side all along. When it worked, it felt almost like a small, quiet miracle, though no one described it that way at the time. It was simply called a good fit, and the day moved on. When it did not work, when a bolt pattern was rotated a few degrees from what was needed, or a shoulder was cut a hair too deep, the correction rarely came with blame. More often it came with a shrug, a fresh dimension noted in pencil, and the unspoken understanding that such mismatches were simply the tax paid for doing difficult work with limited tools and limited time, a tax that everyone in the shop had already learned to expect and to pay without complaint. Material shortages ran through all of this like a persistent undertone, shaping decisions in ways that rarely appeared in any triumphant retelling. A particular grade of steel might simply not be available that month, and a design that had called for it would need to be reconsidered, sometimes substituting a weaker alloy and compensating with a slightly thicker wall, sometimes waiting with evident impatience for a shipment that kept being delayed for reasons no one in the shop could quite explain. Aluminum stock might arrive in the wrong gauge, forcing a bracket to be redrawn around what could actually be had rather than what had first been imagined. There was no romance in this scrounging and substituting, only the steady, somewhat weary practicality of people who had learned that ambition mattered far less than what could actually be measured, cut, filed, and fitted together by the end of the week, and who took a certain quiet satisfaction in making do without letting the finished part show any trace of the compromise behind it. And beneath all of it, quietly present in every drawing and every cut, was the discipline learned outdoors and carried inward, the same caution that had grown out of scorched nozzles and disappointing sputters on the test stands. A dimension checked twice was, in its own small way, cousin to standing well back before ignition. A logged correction in a machinist's notebook was cousin to the anomaly recorded in a logbook after a failed static test. The instinct was the same instinct, only turned toward paper and steel instead of toward fire and pressure, and it moved through these rooms not as a rule imposed from outside, but as a habit absorbed almost without noticing, the way one absorbs the careful pace of someone who has already been burned once and does not care to be burned again, and who would rather spend an extra hour with a file than an extra afternoon explaining a failure. So let the soot and the scorch marks settle for a moment, and let your thoughts drift indoors, away from the open fields and their trembling test stands, into rooms that smelled less of scorched metal. It would be easy, drifting toward sleep, to imagine all of this as merely a preface to the more exciting work that followed, the fitting of engines and the filling of tanks. But it might be gentler and truer to imagine it instead as the quiet backbone beneath everything else, the unhurried craft of lines and dimensions and careful hands that made every later spark of ambition something more than a hopeful guess. Every threaded fitting that turned smoothly, every bracket that sat flush without a shim, every dimension rechecked one more time before the part left the bench, was a small, quiet promise that the larger ambition resting on top of it would not be betrayed by something as ordinary as a careless cut. And soon enough, once the housings and brackets and nozzles had been drawn and cut and filed and set aside on their felt-lined trays, attention would need to turn toward another kind of careful handiwork altogether, toward the people who would wear heavy suits and thick gloves, toward the cloth stitched to hold its shape under pressure, and toward the cable, wound and tested and trusted, that would soon carry both information and hope between the ground and whatever rose gently away from it. So let the metal rest a moment longer on its felt-lined tray, cooling under the shop lights, while our attention drifts toward a quieter room down the hall, one that hummed not with lathes and drills, but with the soft, steady clatter of sewing machines and the murmur of women and men bent close over cloth. It is easy, in the retelling, to let the rockets and their roaring engines crowd out everything else, but if you looked closely enough at the early years of flight, at the capsules and the suits and the miles of cable that threaded through them, you would find that so much of what made those machines trustworthy was stitched, braided, and labeled by hand, in rooms lit brightly enough to catch every loose thread and every uneven seam. There is a tenderness in that kind of labor that rarely makes it into the retellings, though it deserves to, because it is there, in the patient repetition of a needle passing through layered fabric again and again, that some of the earliest promises of survival were quietly kept. Picture, if you can, a long table under fluorescent light, and along it a row of women hunched over what looked at first glance like ordinary sewing work, hemming, gathering, easing one panel of fabric against another. But look closer and you would see that the fabric itself was strange, layered in ways no dress or curtain ever needed to be, rubberized and reinforced, edges bound with tape that had to lie perfectly flat or the seam beneath it might fail under pressure no one in that room could feel until it mattered. These were the people who built pressure suits, the garments meant to hold a small bubble of survivable air around a human body in a place that offered none, and their skill was not incidental to the mission. It was, in its own quiet way, as essential as anything drawn on a blueprint or machined to 1,000th of an inch. A suit that puckered wrong at the shoulder, that bound at the knee, that let a seam gape ever so slightly when the wearer reached overhead, could mean the difference between a controlled motion and a moment of panic thousands of feet above the ground, or farther still in the true dark beyond the air. It is worth resting a moment on how strange and yet how natural it was that these skills came so often from women who had learned their craft not in aerospace laboratories, but in home sewing rooms, in garment factories, in bridal shops and tailoring houses where a crooked seam meant an unhappy customer rather than a life placed in danger. The habits of care translate more easily than we sometimes admit. The discipline of pinning before cutting, of basting before finishing, of trying a garment on a body before calling it done, carried over almost without alteration from ordinary dressmaking into extraordinary spacefaring. Many of the seamstresses who first stitched pressure suits had never imagined their hands would end up shaping something meant to leave the earth, and yet there they were, easing rubberized cloth around a mannequin shaped like a crouching astronaut, checking that a zipper's teeth aligned exactly, that a glove's fingers curled just enough to grip a switch without binding, that a boot's sole held its shape under repeated flexing. The domestic and the extraordinary sat side by side on the same table, sharing the same thread. Fit checks themselves deserve a gentle pause in the telling, because they were neither quick nor glamorous. An astronaut, or in earlier years a test subject standing in for one, would be laced and buckled into an unfinished suit, and then would simply move, reaching, bending, turning at the waist, lifting an arm as though flipping a switch on an instrument panel that did not yet exist in that room. Seamstresses and engineers alike would watch closely, murmuring notes to each other, marking with chalk or pins where the fabric bunched, where a seam pulled too tight across the back, where a glove's wrist joint refused to rotate as freely as it should. Then the suit would come off, the fitter's marks still fresh, and it would return to the workroom for unpicking and re-sewing, sometimes more than once, sometimes many times, until the fit was close enough to disappear from the wearer's notice entirely, which was, in truth, the highest compliment such a garment could receive. A suit that a person forgot they were wearing, even as they reached for a control or turned to check an instrument, was a suit that had been altered patiently enough, adjusted stitch by stitch, until it no longer fought the body inside it. There is something almost meditative in imagining those alteration sessions, repeated late into the evening under bright lights that made every seam and every shadow of a pucker visible. The rubberized layers had to be handled carefully, for a hole poked by a careless pin or a seam sewn too tightly could weaken a spot that might later need to hold pressure against nothing at all, and so the sewing machines ran slower than they might have for ordinary garments, the operators easing the fabric through by feel as much as by sight, listening for the particular rhythm of the needle passing cleanly through layered cloth rather than catching or dragging. Grommets had to be set exactly where a lace or a strap needed to pass, and a grommet set even a little off-center could mean a glove that twisted awkwardly at the wrist or a boot that gapped at the ankle in a way that, on the ground, seemed trivial, but that, in the unforgiving math of survival, was anything but. Not far from these fitting rooms, in another part of the same sprawling effort, other hands were busy with a very different kind of textile work, the sewing of insulation blankets, quilted layers meant to hold heat in or keep it out, depending on which side of a spacecraft's skin they were meant to face. This work, too, called on skills that had migrated from ordinary households and workshops, from quilting bees and upholstery trades, where the logic of layering fabric for warmth or protection was already deeply understood. Multiple layers of thin, reflective material had to be sewn together in patterns that would not shift or bunch when folded, packed and later unfolded in conditions no seamstress in that room would ever personally experience. The stitching had to be even, the seams reinforced at points of stress, and the whole assembly light enough not to add unnecessary weight, for weight in this line of work was never free. Every ounce of thread and fabric had to justify its place by protecting against a hazard, and there was a strange kind of poetry in cloth being asked to hold back the cold of space in one direction and the fierce heat of friction in another, all while remaining pliable enough to fold into a compartment barely large enough to hold it. Not far still from the sewing tables, in rooms that smelled faintly of solvent and warm insulation, other workers bent over benches thick with spools of wire, braiding and binding cable harnesses that would carry signals from switches to instruments, from sensors to displays, threading through a vehicle's frame like a nervous system waiting to be given a body to inhabit. This, too, was work that rewarded patience over haste. A single harness might carry dozens, even hundreds of individual wires, each one meant to travel to a very specific connection, and a technician's task was to keep them organized, labeled, and bound so that no wire strayed to touch another it was never meant to touch. Braiding cable by hand, wrapping it in protective sleeve, tying it off at precise intervals with a particular kind of knot practiced until it became almost unconscious, called on a manual dexterity not unlike lacework or macrame, though the stakes here were rather different than a decorative doily on a shelf. A wire crossed wrong, a connection made in haste, a label smudged or missing, could mean confusion later at a moment when confusion was the one thing no one could afford. It is tempting, hearing all this, to imagine such labor as merely mechanical, hands moving without thought, but that would miss something true and worth holding on to. These workers were required to know their materials intimately, to feel by touch alone whether a cable's insulation had been nicked, whether a stitch had caught the wrong layer of fabric, whether a strap's tension was correct before it was ever tested under load. There was an attentiveness in the work that resembled listening more than seeing, a kind of quiet vigilance carried in fingertips as much as in eyes. And nearby, in yet another room lined with shelves and drawers, other hands were occupied with a task that sounds almost too plain to mention and yet mattered enormously. The sorting and labeling of fasteners, screws, washers, and clips, each drawer marked with a code that some assembler down the line would need to trust completely, without hesitation, while reaching for the exact part a drawing called for. A mislabeled drawer, a bolt of the wrong thread pitch placed where a correct one should have been, could undo hours of careful machining and stitching elsewhere in the building, and so this too was treated with a seriousness that might surprise anyone who imagined it as merely tidying. What ties all of this together? The sewing and the braiding and the sorting is a shared instinct that many of these workers brought with them from ordinary domestic and shop routines long before anyone spoke of spaceflight in their presence. The discipline of counting stitches, of checking a hem twice before cutting thread, of keeping a sewing basket organized so that the right needle or the right size of bobbin could be found without searching, translated with surprising ease into the discipline of building instruments meant to leave the ground entirely. It is worth remembering, too, that many of the people doing this work were not credited by name in the retellings that followed. Their labor folded quietly into the achievements attributed to engineers and pilots and program directors, and yet without their steady hands and their willingness to unpick a seam for the third or fourth time, none of what followed would have held together as well as it did, or as safely. And so, if you let yourself imagine the scene fully, cloth stretched taut under bright lights, cable coiled and labeled in neat loops, drawers of fasteners sorted with quiet, exacting care, you begin to sense that the vehicles which eventually rose from their pads were, in some very real sense, garments and instruments both, stitched and wired and sorted into readiness long before any engine ever fired. The seamstress adjusting a shoulder seam, the technician tying off a final knot in a wiring harness, the assembler double-checking a drawer's label against a drawing, all of them were, without perhaps ever framing it this way to themselves, rehearsing the same quiet promise that the machinists and drafters had made before them, that nothing essential would be left to chance, that every small motion, repeated patiently enough, would add up to something that could be trusted when trust was the only thing that mattered. It is a gentle thought to hold as your eyes grow heavy, this idea of hands stitching and wiring and sorting long into the evening, unseen and unnamed, so that later moments of ascent might rest on something more solid than hope. And once those suits were fitted, once those cables were braided and tested, once every fastener sat in its rightful drawer, the next question waiting patiently in line was how all of this assembled shape, this vehicle built from cloth and cable and careful metal, would move through the invisible resistance of the air itself, and how the engineers would learn, ever so carefully, to listen to what that unseen air was trying to tell them. So let the cloth and cable settle now into their quiet, finished shapes, every stitch and every braid resting easy in the dark, and let your mind drift instead toward a cooler kind of room, one where the air itself becomes the subject of long and patient study. Because once a vehicle has a form, once it has skin and structure and something like a body, there is still the question of how that body will move through the invisible weight of the atmosphere pressing against it, and that question could not be answered by guesswork or by hope. It had to be listened for, slowly, in rooms built specifically for listening. Imagine, if you can, a long chamber with a low hum running through it, a tunnel of moving air built not to fly anything anywhere, but simply to let something small stand still while the air rushed past it, so that people could watch what happened in that meeting of shape and motion. Wind tunnels were strange places in their early years, part laboratory and part patient chapel, where a hush would settle over the room as a fan spun up somewhere unseen, and the air began to move in a way that felt almost deliberate, almost alive. The model makers who built the small shapes tested inside these tunnels were craftsmen in their own right, carving wood and shaping metal into miniature wings and fuselages with a precision that had nothing showy about it, only the quiet insistence that a curve be exactly the curve it was meant to be, because even the smallest inaccuracy could send the readings astray and the whole afternoon's work into doubt. These models were often no larger than a loaf of bread, sometimes smaller, mounted on thin struts or suspended by wires so fine they seemed to disappear into the moving air, and around them the room would grow still except for that steady mechanical breath of the tunnel itself. A technician would check the mounting one more time, running a finger along a seam to be sure nothing had shifted since the last run, and then would step back, and for a moment everyone in the room would simply wait, watching the small shape hold its place inside that invisible current, as though the model itself were the calmest thing in the room, and everyone else had to learn to match it. Data, in those years, did not arrive instantly or cleanly. It came as ink on paper, as needles tracing thin lines across scrolling drums, as tiny fluctuations that a recorder would have to watch closely and mark by hand. There is something quietly moving about picturing a person leaning close to a slowly turning drum of paper, pencil in hand, transcribing the faint tremor of a needle into numbers that would later become a curve on a graph, and that graph, in turn, would become a decision about how a wing should be shaped or how far a control surface should extend. The recorders who did this work rarely appear in the grander tellings of the story, and yet without their steady attention, the roaring engines and soaring launches that came later would have had nothing solid beneath them, no honest accounting of how air actually behaved instead of how it was assumed to behave. And the smoke had its place in this work as well, drifting in thin ribbons through the tunnel so that the eye could trace what the wind alone would leave invisible. Someone would release a careful thread of it near the model, and for a few seconds it would curl and bend and separate around the little wings and fins, showing in ghostly outline where the air flowed smoothly and where it broke apart into turbulence. Watching smoke behave this way must have felt almost like reading handwriting left behind by something that could not otherwise speak, and the analysts standing nearby would sketch what they saw, marking where the ribbon smoothed into calm lines and where it tangled into knots, because that tangling told them something a number alone could not, about where the design still had roughness it needed to shed. The work did not move quickly, and there is no use pretending otherwise, because that slowness was the whole point of it. A single test might mean adjusting the angle of a model by a few degrees, running the tunnel again, waiting for the readings to settle, recording them, adjusting again, and repeating this pattern through an entire afternoon, sometimes for many afternoons in a row, until a small stack of numbers had grown into something like a pattern, and the pattern had grown into something like understanding. It was a rhythm built on repetition rather than revelation, closer to tending a garden than solving a riddle in a single insight, and the people who did this work seemed to have accepted, without much complaint, that understanding the air would ask for patience the way a slow-growing thing asks for patience, offering itself only a little at a time. There is a gentle irony in how much of this work depended on comparison rather than certainty, because no single run of a wind tunnel ever proved much on its own. What mattered was how one run compared to the last, how a change in shape shifted the numbers by a small margin, how a curve on a chart bent slightly differently than the curve from the week before. Engineers would gather around long tables afterward, sheets of data spread before them, comparing columns of figures with the same careful attention a jeweler might give to matching stones, looking for whether a modification had genuinely improved the behavior of the model, or whether the shift in numbers was simply the ordinary noise of imperfect measurement. This kind of comparison required not just skill, but a certain temperament, a willingness to sit with numbers that refused to resolve cleanly, and to keep looking rather than declaring victory too soon. It is worth pausing here in this hushed and unhurried atmosphere to acknowledge that not everything the early aerodynamicists believed about the air has held up cleanly over time. Some interpretations of those early tunnel readings, especially in the very first years of powered flight research, remain gently disputed even now, historians and engineers looking back at old data sets and disagreeing, quietly and without much drama, over how certain results should be read. There are questions about whether some early measurements of lift and drag were skewed by the small scale of the models, or by the walls of the tunnels themselves interfering with the very air they were meant to measure freely, and whether some of the conclusions drawn from those imperfect setups were embraced a little too readily simply because they were the only numbers available at the time. None of this uncertainty should trouble you as you rest, because it was, and still is, simply part of how understanding builds itself over time, layer over layer, correction over correction, each generation of engineers looking back at the last with a mixture of respect and gentle skepticism. What matters more than any single disputed number is the atmosphere in which all of this happened, an atmosphere that was, in its own way, remarkably calm despite the enormous stakes quietly humming beneath it. There was no room in a wind tunnel for excitement in the dramatic sense, no cheering when a model held steady, or when a curve smoothed out the way an engineer had hoped. Instead, there was a kind of contained satisfaction, a nod exchanged between a technician and an analyst, a note added carefully to a logbook, and then, almost immediately, the quiet turning of attention toward the next variable to test, the next small adjustment to make. It was a culture built on the assumption that no single afternoon would deliver the answer, only another fragment of it, and that the accumulation of many such fragments over months and years was the only honest way toward real knowledge. Acoustic chambers offered their own version of this same unhurried attentiveness, though the questions asked there were different, concerned less with the shape of airflow and more with how sound moved through structures and how vibration might reveal weaknesses invisible to the eye. In these rooms, padded and strangely silent in a way that made your own breathing sound loud, technicians would scent carefully controlled tones through materials and structures, listening for how sound reflected or dampened or resonated in ways that hinted at hidden flaws. Just as the tunnel technicians read air through smoke and needles, the acoustic engineers read structure through echo and tone, and both groups shared the same underlying belief that the physical world, if listened to carefully enough, would eventually reveal its own limits and its own quiet warnings. There is something soothing in imagining these two kinds of rooms existing side by side in the larger story of early flight and rocketry, one filled with moving air and drifting smoke, the other filled with padded silence and carefully pitched tones, each one a place where humans slowed themselves down deliberately in order to hear something that would otherwise pass by unnoticed. Neither room rewarded impatience. Neither room offered dramatic revelations on command. What they offered instead was the slow accumulation of trust, built log entry by log entry, until designers elsewhere could take those numbers and use them with a reasonable confidence that they were not simply guessing at how their creations would behave once they left the safety of the workshop. And it was not only engineers who inhabited these spaces, but a whole quiet ecosystem of specialized roles working in close, unspoken cooperation. There were the model makers shaping wood and metal with hand tools that demanded steady patience rather than quick strength, the mounting technicians who positioned each test piece with the same care a surgeon might bring to an instrument, The data recorders bent over their scrolling paper strips, the analysts comparing charts spread across long tables under humming lights, and, threading through all of them, a shared unspoken respect for the idea that no single person's intuition, however skilled, could substitute for the slow, careful gathering of evidence. This was collaboration without much need for words, each person trusting the next to have done their portion of the work honestly, each measurement passed along like a small inheritance to be examined further rather than accepted blindly. Over time, across many wind tunnels and many acoustic chambers, this style of patient, comparative learning built something larger than any single design improvement, something closer to a discipline, a way of thinking about uncertainty that would carry forward into every later stage of flight and rocketry. Engineers began to trust the process itself almost as much as any particular result, understanding that today's careful measurement might be revised by tomorrow's better instrument, and that this was not failure, but simply how honest knowledge grew. It is a gentler way of thinking about progress than the one often told in dramatic stories of sudden breakthroughs, and perhaps a truer one, this slow layering of runs and logs and comparisons, each one a small brick laid carefully atop the last. As you rest here now, picture one final image from these rooms before we move on. A technician switching off the tunnel at the end of a long day, the roar of moving air fading into an ordinary stillness, papers gathered and stacked, models gently unclipped from their mounts and set back into padded boxes for the next morning's work. There is a certain tenderness in that end-of-day quiet, the sense of unfinished work being set down carefully rather than abandoned, ready to be picked up again with the same patience tomorrow. And once the air itself had been listened to closely enough, once its behavior had been measured and compared and cautiously trusted, the next question waiting in the soft dark ahead concerned something far less abstract and far more physical, something that would need to be handled not just with careful eyes and steady hands, but with real caution, for it was time to turn toward the fuels themselves and the fittings meant to hold them safely, and the quiet, deliberate discipline required whenever something so powerful had to be treated with such very careful respect. There is a certain had to be treated with such very careful respect. So let the hum of the wind tunnel fade all the way down now, past the last whisper of moving air, into the kind of silence that only settles over a room once everyone trusted has gone quietly home for the night, and let your mind drift, soft and unhurried, toward another kind of room altogether, one that smells faintly of solvent and metal rather than paper and pressed models, where the work waiting to be done was not about watching air slip over a shape, but about handling something that could not be allowed even the smallest carelessness. This is the room of fuels and fittings, of tanks and hoses and pumps, where the people who kept rockets fed were learning, patiently and without any hurry at all, how to make peril feel almost ordinary through sheer repetition of care. Picture, if you can, a low building set some distance away from the offices and the machine shops, separated not out of secrecy, but out of simple prudence, the way you might keep a stove a careful few steps back from anything that could catch too easily. Inside, the light tends to be plain and even, chosen for clarity rather than warmth, falling over rows of drums and cylinders and coiled lines that seem, at first glance, almost unremarkable. But nothing in that room was ever really unremarkable, not once you understood what waited inside those containers. Propellants, after all, are strange things to hold in the hand, and stranger still to trust. Chemicals chosen precisely because they wanted, with a kind of eagerness, to release their energy all at once, and so the entire shape of the work there bent itself around a single quiet purpose, which was to let that eagerness happen only when it was meant to, and only in the way it was meant to, and never a moment before. You might imagine the fuel handlers moving through their morning with a particular unhurried rhythm, pulling on heavy gloves before they so much as touched a valve, the leather or rubber worn soft in places from years of exactly this same motion, repeated by exactly this same sort of careful hand. There is something almost ceremonial in the putting on of protective gear, not because anyone thought of it as ritual in the moment, but because repetition itself tends to take on the shape of ceremony once it has been done enough times by enough careful people. A mechanic checking a seal does not simply glance at it and move on. He presses it, turns it, sometimes crouches low with a small light to look at an angle no casual eye would think to check, because a seal that looks fine from standing height might tell an entirely different story from an inch away. It was in these small bendings and crouchings, these unglamorous postures of attention, that safety was actually built, not in any grand gesture, but in the sum of many tiny ones. Let yourself picture the storage rooms themselves, cool and dim, lined with tanks that sat with a patience of their own, waiting for their turn to be measured, drained, refilled, tested again. Inspectors moved among them with clipboards that would later give way to forms and then to logs, and eventually to something like a formal language all its own, filled with numbers and dates and initials, each one a small promise that someone had looked and looked carefully and found nothing wrong, or found something wrong and made it right before moving on. There is a peculiar comfort in that kind of paperwork, dry as it might sound to describe. It is the comfort of knowing that forgetting has been made difficult on purpose, that memory has been handed over to ink rather than left to trust in any one person's recollection of what they meant to check yesterday. Consider, too, the hoses and lines running between the tanks and the vehicles they were meant to feed, snaking along in ways that had to be planned as carefully as any drawing in the drafting rooms we lingered in earlier. A fitting that seemed almost too simple, a joint no larger than a fist, might carry within it the difference between a smooth and ordinary afternoon and something no one wanted to imagine. And so those fittings were checked not once, but many times, by different hands on different days, because a single person growing used to a task can begin, without meaning to see what they expect to see, rather than what is actually there. It was not distrust exactly, this habit of checking each other's checking, but something gentler and wiser, an acknowledgement that everyone grows a little tired now and then, and that tiredness has no place anywhere near a valve meant to hold back so much stored power. If you listen closely to the quiet of that memory, you might almost hear the particular sound of a wrench being set down deliberately rather than dropped, the soft click of a gauge being tapped to make sure its needle was not simply stuck in a comfortable lie. Pressure had to be watched the way the wind tunnel technicians once watched their tufts and smoke, not glanced at once and trusted forever, but observed again and again, because pressure, like moving air, has its own moods, and those moods matter enormously when the thing containing it is meant to be trusted with human lives. A pump that ran a little too hot, a line that trembled just slightly more than it had the day before, these were treated not as nuisances to be waved away, but as small voices worth listening to, the same way a strange whistle in a tunnel's airflow was never simply ignored. And here is where the discipline of waiting enters this quiet story, because so much of this work turned out to be about patience stretched thin and held anyway. Fuels of certain kinds could not simply be loaded and left. Some had to be handled within careful windows of time, watched for temperature, checked against the creeping possibility of pressure building somewhere it should not. Crews learned to build their days around these windows the way a household might build itself around the rising and setting of the sun, not fighting the rhythm, but shaping their lives to fit inside it. There would be a scheduled hour to begin fueling, and everyone understood, without needing to be told twice, that the schedule bent to the chemistry and never the other way around. If a reading came back wrong or a valve seemed the smallest bit reluctant to close as firmly as it should, the answer was never to push ahead hopefully. The answer was to stop, to look again, to call for another set of eyes, and if necessary, to wait, sometimes for hours, sometimes for another day entirely, until whatever had seemed uncertain had either resolved itself under careful inspection or been replaced outright. It is worth resting for a moment on how strange and admirable that kind of patience really is when you think about it slowly rather than rushing past it. There is no glory in waiting, No one remembers, in the ordinary telling of these stories, the afternoon of fueling was postponed because a gauge looked slightly off, or the morning an entire schedule shifted because clouds gathered in a way the weather officer did not like. And yet it was precisely these unremembered pauses, stacked one atop another over years, that let the whole practice of handling such volatile substances become something closer to routine, something survivable, something that could be done again and again without catastrophe becoming an accepted cost of doing the work at all. Every quiet postponement was itself a kind of quiet victory, though it rarely felt like one to the people standing in the wind, checking their watches, waiting for word to proceed. Weather, in fact, wove itself through this part of the process in ways you might not expect if you pictured propellant work as something confined entirely indoors. A storm sitting too close on the horizon, a certain restless quality to the clouds, humidity climbing higher than comfort allowed. Any of these could be reason enough to hold everything in place a little longer. Static charge, invisible and easy to forget about in ordinary life, became something to think about quite seriously around volatile vapors, and so grounding cables were checked and rechecked. Footwear was chosen with unusual care, and even something as simple as the friction of fabric brushing against fabric was, on certain days, treated as a real and serious consideration rather than an afterthought. It might sound almost excessive to imagine grown engineers pausing to think about the static in someone's jacket, but that same instinct for taking the smallest hazard seriously was precisely what let the largest hazards be managed at all. Within the storage rooms and along the fueling lines, a whole quiet vocabulary of approvals grew up over time, though it never announced itself as such. No single tank was filled, no valve opened for a real test, without someone, and often several someones, signing their name to a form that said, in effect, "I have looked, and I believe this is safe enough to proceed." There is something moving in imagining all those signatures accumulating in drawers and files over the years, ordinary names written in ordinary ink, each one representing a person who took a moment, however small, to stand between careless motion and disaster. It was not heroism in any dramatic sense. It was simply diligence offered again and again, day after unremarkable day, until diligence itself became something like a tradition passed from one careful hand to the next. Woe, and slowly, through exactly this kind of accumulation, trust began to grow, not blind trust, never blind, but a trust built the way stone walls are built, one carefully placed piece resting atop another until the whole structure could bear real weight. Mechanics trusted the seals because they had checked them themselves, and trusted the checking of others because they had seen over years how seriously that checking was taken. Inspectors trusted their instruments because those instruments were themselves checked and calibrated on their own quiet schedule, tested against known standards the way a cook might taste a dish against a memory of how it ought to taste. Crews trusted the written procedures, not because the procedures were perfect from the very beginning, but because each one had been shaped and reshaped by lessons learned the hard way, refined until following them felt less like obeying a rule and more like walking a path someone wiser had already worn smooth through careful, repeated use. What if you picture a single fueling operation from a slight distance, the way you might watch a familiar street from an upstairs window? You would see how unhurried it truly looked, despite the danger folded quietly within it. Figures in protective gear moving without haste, checking gauges, exchanging a few words, waiting through a pause here, resuming again there. It might look almost dull to an outside eye expecting drama, and that dullness, that careful lack of excitement, was in fact the entire point, the hard-won reward of so much earlier caution. Danger handled well tends to look, from the outside, remarkably like patience. As the evening settles a little deeper now, imagine one last quiet scene from these fueling yards and storage rooms, gentler than you might expect given everything stored inside them. A technician walks the length of a checked and rechecked line one final time before the light fades, running a gloved hand almost absent-mindedly along its length, feeling for anything that might not match what the eyes alone reported. Finding nothing wrong, he makes a final small mark on his sheet, gathers his tools, and locks the gate quietly behind him, leaving the tanks and lines to sit through the darkness in exactly the same careful order they were left in the evening before. There is a peacefulness to that image that might seem strange given the volatility resting so near at hand, but it is precisely that peacefulness earned through so many small, disciplined choices that made it possible for this work to continue at all. And once the fuels had been measured and the fittings checked and the long, patient rhythms of waiting and approving had settled into something like a heartbeat of their own, there remained only the final gathering of all this care into a single, quieter kind of evening, one spent not among tanks and gauges, but around tables covered with papers and checklists, where everything learned in the workshops and tunnels and fueling yards alike would need to be drawn together, item by item, into the hushed and steady calm of the night before a launch. So let the gate swing shut on that quiet yard of tanks and lines, and let your mind drift now toward a different kind of stillness, one that gathers not around fuel and metal, but around long tables spread with paper under humming lights. If the fueling technician's careful walk through the dark was a kind of hush before a single held breath, then the rooms we come to now hold a hush of another sort altogether, one built from many hands passing many pages back and forth, checking, initialing, checking again, until the whole enterprise seemed to settle into something almost like sleep itself, a readiness so complete that it no longer needed to announce itself with any fuss. Picture, if you will, a hangar or a low cinder block building near the base of a gantry, its windows fogged faintly with the cool of early evening, and inside, a scattering of engineers and technicians moving without hurry from station to station, their voices pitched low, their movements almost ceremonial in how deliberate they had become. Some carried clipboards thick with pages bound at the corner by a metal clasp gone slightly rusted from handling. Others carried nothing but a pencil and the quiet authority of having done this particular task so many times before that their hands seemed to know it better than their thoughts did. There is a particular kind of tiredness that settles into people during these final hours, not the tiredness of exhaustion, but the tiredness of concentration held gently for a very long time, like a muscle that has learned to relax even while remaining alert. The checklist itself, when you think about it slowly, is a strange and rather beautiful invention. It asks almost nothing of imagination and everything of patience. Each line waits to be read, considered, and marked, and though the words themselves are plain, almost stubbornly unpoetic, there is something moving in the way they accumulate, page after page, into a kind of collective memory of everything that could go wrong and everything that had been done to make sure it would not. Verify connector torque, confirm continuity, inspect for foreign object debris, compare drawing revision to as-built configuration. Each phrase sounds almost mechanical when spoken aloud, and yet within each one lives an entire small history of some earlier failure, some earlier oversight, folded now into a single line so that no one would ever need to learn that particular lesson twice. One table, a technician might be laying out a row of fasteners recovered from a panel that had just been reopened for inspection, counting them softly under her breath, matching the number against a tag that had traveled with the panel since it was first installed weeks before. If one bolt seemed to be missing, the room would not panic, not exactly, but a certain stillness would deepen, conversations pausing as people quietly began retracing steps, checking toolboxes, checking pockets, checking the floor beneath workstands with flashlights held low and careful. Sometimes the missing item turned up in a drawer where it had been set down absent-mindedly hours earlier. Sometimes it never turned up at all, and the response to that was not blame but calm, methodical accounting, a decision made collectively about whether the vehicle could proceed and under what allowances, written down, initialed, filed away as its own small piece of history. There was a peculiar comfort in that discipline, the sense that no mistake, however small, was allowed to disappear quietly into forgetfulness. Everything had to be seen, named, and resolved before anyone could rest easy enough to move forward. Elsewhere, in the same building, Someone might be running a calibration check on an instrument that would, in only a matter of hours, measure something as fine as a fraction of a degree of temperature drift inside a chilled propellant line. The instrument sat connected to a reference source, its needle or its digital readout compared patiently against a known standard, and if the two disagreed even slightly, an adjustment would be made, then checked again, then checked once more, because there was no room in this particular kind of trust for anything left to assumption. It is worth pausing here in the quiet of your own resting mind to consider how strange and how wonderful it is that human beings learn to build such trust not through grand gestures, but through this kind of humble, repetitive, almost tender attention to small numbers agreeing with other small numbers. The language spoken around these tables had its own particular music, low and unhurried, full of phrases that meant very precise things to the people using them, even though they might sound almost like incantations to anyone listening from outside. Go for closeout, stand by for cross-check, concur, non-concur with explanation to follow. There was a rhythm to it, call and response, one voice reading a line and another voice answering with a single flat word that carried enormous weight, precisely because it was so plain. Concur meant that another set of eyes had looked at the same problem and arrived independently at the same conclusion. It was a small word doing the work of many, quietly guarding against the particular danger of any one person seeing what they expected to see, rather than what was actually there. Somewhere near the tables, coffee cups gathered in small clusters, their contents gone lukewarm and mostly ignored, held more for the warmth in the hands than for the taste. Someone might refill a pot on a hot plate in a back corner, the smell drifting faintly through the room, mixing with the fainter scent of solvent and machine oil that seemed to live permanently in the fabric of these buildings, no matter how many times the floors were swept. If you close your eyes and imagine standing quietly in the corner of such a room, you might notice how the overhead lights hummed faintly, how footsteps on painted concrete made a particular soft scuff, how every so often someone laughed quietly at some small shared joke about a stubborn fitting or a drawing revision that never seemed to match the parts it was meant to describe. These moments of gentle humor were not distractions from the seriousness of the work, but part of what made the seriousness bearable, a way of staying present through hours that asked so much sustained attention. As the evening deepened, groups would gather for what some called the walk-down, moving slowly along the length of the vehicle itself, following printed sheets that guided them past valve after valve, connector after connector, comparing physical reality once more against the paper record that claimed to describe it. A flashlight beam might pause on a fitting, someone leaning close to read a stamped serial number, checking it against a list, nodding, moving on. Nothing about this process looked dramatic from a distance. It might have looked, to an outside eye, almost tedious, a parade of small confirmations offered up again and again to no visible audience. But within that tedium lived the entire accumulated wisdom of every workshop and wind tunnel and test stand that came before, distilled now into a sequence of quiet, careful steps that asked only to be followed faithfully, one after another, without shortcut. It would happen, now and then, that a discrepancy surfaced during one of these late checks, some measurement slightly out of tolerance, some tag missing its expected signature, and in those moments the room would not rush toward a decision. Instead, there would be a kind of unhurried deliberation, engineers pulling out earlier records, tracing a part's history back through its manufacture and testing, weighing whether the discrepancy mattered enough to halt progress or whether it fell safely within the boundaries already understood and accepted. Sometimes these deliberations stretched long into the night, voices low, coffee refreshed once more, the tables slowly filling with more paper as calculations were checked and rechecked, and when at last a decision came, whatever it was, it arrived not as a sudden verdict, but as the quiet conclusion of a process that had given every voice in the room its fair chance to be heard. There is something almost meditative in imagining this collective vigilance, this willingness to sit with uncertainty rather than rush past it. In a strange way, the calm of launch eve was not the absence of tension, but its careful, patient management. Tension folded so many times into checklists and cross-checks and independent verifications that it lost its sharp edges and became instead something closer to attentiveness, something almost restful despite how much depended on it. The people gathered around those tables were not calm because nothing mattered. They were calm because so much had already been done, so thoroughly and so many times, that very little remained to fear except the ordinary uncertainty that clings to any undertaking of consequence. As the hours grew later still, some of the crew might step outside briefly for air, standing beneath a sky just beginning to hold its first scattering of stars, glancing back at the vehicle standing quiet and illuminated against the dark, its surface catching floodlight in a way that made it look almost patient itself, waiting without impatience for whatever the coming hours would bring. There is a particular stillness to a launch site at night that seems to hold everything in suspension, the ordinary sounds of distant traffic or insects in the grass mixing strangely with the occasional hiss of venting gas or the low hum of ground equipment, as if the whole scene existed somewhere between the everyday world and something not quite of it. Inside again, the paperwork would near its final pages, signatures accumulating like small votes of confidence, each one a person's willingness to say, in effect, that they had looked closely and found nothing that should stop what was coming. There is something quietly moving in that act of collective signing, dozens of individual judgments layered one atop another until they formed something sturdy enough to support the weight of an actual departure from the ground. No single person carried that weight alone. It had been distributed, patiently and deliberately, across every workshop and test stand and tunnel and table that came before, until it settled finally into this last calm evening of ink and coffee and quiet nodding agreement. And when the last checklist had been closed, the last tag verified, the last discrepancy resolved or formally accepted, there would come a kind of settling in the room, shoulders easing slightly, voices softening further still, as though everyone present understood without needing to say so that they had done what could be done, that the rest now belonged to weather and physics and the unhurried turning of the clock toward morning. It is worth resting for a moment on that feeling, the particular peace of having prepared as fully as human care allows, because it was that peace, built table by table and checklist by checklist across so many years and so many quiet nights like this one, that slowly turned an unlikely dream into something people could actually trust enough to climb aboard. And it is that same slow accumulation of trust which, gathered now from workshop and tunnel and fueling yard and table alike, would finally carry this story upward into the wider habit of reaching toward the sky that had, by then, only just begun to take shape. So let the evening settle a little further now, the way it always does when the last light in a workshop finally goes dark and someone locks the door behind them without quite wanting to, because there is always one more thing that could be checked, one more measurement that could be taken again just to be sure. That reluctance to leave, that quiet itch to double back and verify what has already been verified, is perhaps the truest inheritance of everything we have wandered through together tonight, from the first spark struck in a cluttered workshop to the hush of a launch eve room where checklists lay closed and coffee had gone cold in careful hands. It is worth letting that thought breathe for a moment, because it is not really a story about rockets at all, not at its core. It is a story about habits, about the slow and patient repetition of small, unglamorous acts until they became something larger than any one person could have built alone, something that outgrew the walls that first held it and drifted, almost without anyone noticing, into the wider air of everyday life. Think back, if you like, to that first workshop, the one lit by lamplight and stubbornness, where metal was shaped by hand and mistakes were corrected by feel rather than formula. There was no promise then that any of it would lead anywhere beyond the walls of that room, no certainty that the sparks flying from a file or the smell of hot metal would ever amount to anything the wider world would notice, and yet something in the way those early tinkerers approached their failures, not with despair, but with a kind of weary curiosity, planted a seed that would outlast them. They measured twice, adjusted, and tried again, not because they were certain of success, but because trying again was simply what one did, the way breathing is simply what one does, without needing to be told to continue. That instinct, so ordinary and so easily overlooked, is the same instinct that later filled test stands with engineers watching gauges flicker toward failure, and then, undeterred, walking back to their drafting tables to begin sketching improvements before the metal had even cooled, the scorch marks still faintly warm beneath their fingertips. It is strange, in a way, how much of this history moves not through triumph but through repair. Every failed test, every fractured seam, every scorched valve became less an ending and more an invitation to ask a better question, a nudge toward some detail that had gone unnoticed until it finally insisted on being seen. The people who did this work, we might imagine, must have possessed a peculiar kind of patience, the ability to look at wreckage and see instruction rather than defeat, to walk among broken parts and hear them quietly offering their lessons rather than their complaints. And slowly, as those lessons accumulated, they became something you could pass on, a note scrawled in the margin of a logbook, a modified drawing pinned above a workbench, a story told over dinner about the time something almost worked, and what had to change before it finally did. Craft, after all, does not survive by memory alone. It survives by being written down, corrected, and handed forward, again and again, until the handing forward itself becomes a kind of tradition. That handing forward is perhaps the quiet miracle hidden inside all of this. Picture the machine shops where new apprentices stood beside older hands, learning not just how to cut metal to tolerance, but how to listen to a machine the way one might listen to breathing, sensing almost intuitively when something was not quite right, when a sound had shifted just slightly from the rhythm it ought to keep. Picture, too, the sewing rooms and cable lofts, where cloth and wire were shaped with the same devotion once reserved for finer things, because a single loose stitch or frayed strand could undo months of careful engineering, could turn a triumph into a tragedy in the space of a heartbeat. These were not separate worlds from the drafting rooms and wind tunnels. They were all part of one long conversation, carried across benches and generations, about how to make something reliable enough to trust with a life, and then trust it again and again, until trust itself became a kind of craftsmanship. And it is trust, more than triumph, that seems to sit at the center of this whole unfolding history. Trust built slowly, through documentation and repetition, through checklists that grew longer, not because people were more anxious, but because they had learned, sometimes painfully, exactly what could go wrong if a single step were skipped or a single detail assumed rather than confirmed. Every wind tunnel test that revealed some invisible flaw in a shape, every fitting checked twice before fuel was allowed near it, every careful hand steadying a valve in the cold hours before dawn, all of it fed into that same slow current of accumulated confidence, a current running quietly beneath the more visible drama of ignition and flight. It is easy, looking back from a distance, to imagine these moments as dramatic, filled with tension and roaring engines, but so much of what made spaceflight possible happened quietly, in a checklist revised after a small oversight, in a training room where the same procedure was practiced again and again until it became almost like breathing, in a family gathered around a table listening to a father or mother describe, with careful understatement, the ordinary work they had done that day to help something leave the ground. There is something deeply human in that ordinariness, in the idea that the vast, glittering achievement of reaching space was built not by singular flashes of genius, but by thousands of small acts of diligence, repeated until they became culture, repeated until they no longer needed to be discussed, because everyone simply understood how things were done. It is worth imagining those training rooms, filled with astronauts and technicians alike, going over procedures so many times that the sequence became instinct rather than memory, because in an environment where surprises could be fatal, instinct built through repetition was the safest kind of knowledge, safer even than brilliance, because brilliance can falter under pressure while instinct, worn smooth by practice, tends to hold. And it is worth imagining, too, the shop floors where retired engineers, their hands steady from decades of practice, quietly taught younger colleagues the small, unwritten truths that no manual could quite capture: how a bolt should feel when it is properly seated, how to sense just from sound when a machine was behaving as it should, how silence itself could sometimes mean trouble as clearly as any alarm. This passing of knowledge, hand to hand, generation to generation, did not stop at the edges of engineering. It slipped into families, into communities that grew up around launch sites and testing grounds, where children absorbed, without quite realizing it, the rhythms of countdown and preparation, the vocabulary of stages and boosters, the quiet pride of watching something rise into the sky that their parents had helped, in some small way, to build. It became, in time, less a specialized craft and more a shared culture, a spacefaring habit stitched into daily life, one that could be found not only in control rooms and clean rooms, but in dinner conversations, in scrapbooks kept on shelves, in bedtime stories not unlike this one, passed down as gently as any lullaby, carrying forward the same patient rhythm that had once lived only in workshops and test stands. And if we allow ourselves to drift back through everything we have wandered through tonight, the sparks in workshops, the failures on test stands, the careful lines drawn in drafting rooms, the patient hands shaping cloth and cable, the listening ears tuned to the whisper of wind tunnels, the careful custodianship of fuels and fittings, and finally the steady, quiet vigilance of launch eve tables, we begin to see that none of these moments were separate stories at all. They were chapters of the same long apprenticeship, each one teaching the next generation not just what to build, but how to hold patience, humility, and care as tools every bit as essential as any wrench or slide rule, tools that could not be measured on any gauge, but were nonetheless felt in every steady hand that came after. It is tempting, when we speak of rockets and spacecraft, to imagine only the grand spectacle, the roar, the flame, the impossible defiance of gravity, the sky splitting open with light. But if you lean closer to the truth of it, as we have tried to do together tonight, you find something gentler and in its own way more remarkable: the sight of ordinary people returning again and again to their work, undeterred by failure, unhurried by ambition, simply devoted to doing the next careful thing correctly. That devotion, multiplied across decades and passed like a family recipe from one careful hand to another, is what quietly transformed a scattering of small workshops into an entire spacefaring habit, a way of living and working that treats the impossible as simply another problem to be solved patiently, one measurement, one repair, one checklist at a time, one quiet evening after another, until the habit no longer felt like effort at all. There is a kind of comfort in remembering it this way, in resisting the pull towards spectacle and choosing instead to notice the steady human rhythm beneath it all, because if the dream of reaching space had depended only on brilliance or boldness, it might have flared briefly and faded, as so many dreams do, burning bright for a season before dimming into memory. But it did not rely on brilliance alone. It relied on the unremarkable virtues: patience, precision, the willingness to fail quietly and try again the next morning, virtues that do not announce themselves loudly, but accumulate almost invisibly, the way frost gathers overnight without anyone watching, until one day they lift something enormous off the ground and send it climbing toward a sky that no longer feels quite so unreachable. So when you next imagine a rocket rising, perhaps let your mind wander not only to the fire and thunder of its ascent, but to the small, quiet rooms that made that moment possible: the workshop where someone first dared to sketch an impossible shape, the test stand where failure taught its first patient lesson, the drafting table where lines were erased and redrawn 100 times before they finally felt right, the sewing room where careful stitches held together something meant to fly higher than anyone in that room would ever travel themselves, the wind tunnel where air was coaxed into confessing its secrets one gentle current at a time, the fueling yard where caution was treated as a form of respect rather than fear, and the table, at last, where checklists were closed one by one in the hush before dawn. each of these rooms, in its own quiet way, taught the same lesson, that greatness is often built not from grand leaps, but from small, steady steps repeated with care until they become a kind of faith, a faith held not in words, but in the calloused hands and steady eyes of the people who carried it forward. And so it is enough, tonight, to simply hold that thought gently as the story settles, that somewhere between the flicker of a workshop lamp and the blaze of an engine igniting against the dark, there exists a long, unbroken thread of human patience, stitched together by generations of hands that measured, repaired, documented, and tried again, hands that passed their knowledge quietly from shop floor to training room to kitchen table, never demanding recognition, only continuation. That thread is what carried us, quietly and steadily, from small shops into the wide reach of space, and it is what continues, even now, to carry us forward, not through sudden brilliance, but through the calm, familiar rhythm of care, repeated so faithfully that it began to feel less like effort and more like a kind of inheritance, something each generation simply received and gently passed along. Let that be enough for tonight, then. The rockets resting quietly in memory, the workshops dim and peaceful, the long, patient story finally allowed to rest alongside you as your own eyes grow heavy, the last lamp dimming softly somewhere far off, and the night settling gently around this last small, steady thought, as if it too were closing its own quiet checklist before drifting, unhurried, toward sleep.